It's the advent of Cyber 2023, and we are on a mission to save Christmas. McGreedy, you are going down. I have the THM Army with me. Let's go. Yeah. I'm a Papa Shell, but not what you think. Who am I root? Make it dead a leg sink. We are on a mission, we're here to save Christmas. McGreedy's going down, forget about the riches. Rumors gone around, like Skitty's got snitches. It's an insider threat, and everyone's suspicious. Recon McRed is hunting down a witness. He says he needs our help, so power on your system. Get your black hoodie, boot up the attack box. Hackers come together and take command of the SOC. It's the THM Army. McGreedy will get caught from the 0x1 all the way up to the gods. And we are live. What is up, everyone? Welcome back to my live stream. My name is Tyler Ramsbey, and we are on a mission to save Christmas. Every single night, we are working live through the advent of cyber challenges, and we have made it to day 6. We are slowly on our way to saving Christmas. And hey, if you're new here, I go live around this time every single night this month as we work through these advent of cyber challenges. Sometimes they take 30 minutes, sometimes they take an hour. I never know how long they're going to take. What I do that's probably a little bit different than other content creators is I do not prep this ahead of time. So this is me working through it live, making silly mistakes, and hopefully learning together. So if you haven't already done today's challenge, would encourage you to boot up the machine and follow along with me. If you already did it, well, hey, just hang out and you can watch and see what silly things I do. Or maybe, just maybe, you might be able to learn something from my technique or learn what not to do from my technique. So without any further ado, let me share my screen. I want to make sure I have all the chat stuff pulled up. Check LinkedIn over here. Got Twitch on the screen. Got YouTube on the side screen. All right, Andre said just finish it. Easy and fun. All right, word, dude. Let's do it. Actually, I'm not going to zoom in because that messes it up. So I launched the machine. Looks like it's a game today, but haven't read through any of it yet. Throughout the merger, we have detected some worrying coding practices from the South Pole Elves. Those dang South Pole Elves. To ensure their code is up to our standards, some frostlings from the South Pole will undergo a quick training session about memory corruption vulnerabilities, all courtesy of the B team. Welcome to the training. So what are our learning objectives today? Well, number 1, understand how specific languages may not handle memory safely. Number 2, understand how variables might overflow into adjacent memory and corrupt it. And finally, 3, exploit a simple buffer overflow, directly change memory you are not supposed to access. Before moving forward, review the question in the connection card below. Do I need to start a VM today? Yes, done. Is there a direct link available? Yes, done, right there. So if you haven't already, do that, and so you can open up this link. The game. In this game, we will play as cat or mouse. Our objective is to save Christmas by buying the star for your Christmas tree from Van Frosty. In addition to the star, well, you can buy as many ornaments as you can carry to decorate your tree. To gain money to buy things, you can use a computer to do online freelance programming jobs. You can also speak to Van Holly to change your name for a fee of 1 coin per character. He says that this is totally not a scam, bro. Yeah, got that crypto scam going. He will actually start calling you by your new name. He is, after all, into identity management. Is this a bug? Well, before the training even starts, Vanjali approaches McHoneybell and says that they've been observing some weird behaviors while playing the game. They think the ghost of Christmas past is haunting it. Oh no. McHoneybell asks them to reproduce what they saw. Vanjali boots up the game and does the following, which you are free to replicate too. Okay, let's do it. Let's follow along. Ask the computer to get us 13 coins. Ask Von Holly to change your name to Scrooge Rocks. And suddenly, we have 33 coins out of nowhere. Okay. Game controls, move, space, tab is debug panel, backspace is reset inventory. To finish the game, all you need to do is get a start, put up on your Christmas tree. All right, do I need to zoom out a little bit? There. All right, space. After you get the star, just interact with the Christmas tree, bro. That's it. You're free to buy as many additional ornaments. Okay, who do I talk to? This dude? Or this dude? Howdy, cat or mouse. I can change your name from 1.1 coin per character. No, I need to use a computer. No. I can't do it yet. I just made my name blank because I couldn't type anything. That's cool. All right, computer. Oh, every time I do it, I get a coin? Yeah, that's definitely how it works. You just punch a computer. I'm not here. Let's point this way. Yeah, we just punch that computer. Punch, punch, punch. We boxing it now. Floyd Money Mayweather better watch out. There we go. We got our 13 coins. Yo, you guys see our 33 coins? Should be 1337 coins, but. All right. Van Jolly explains that when you change your name to anything large enough, the game goes nuts. Typical Buffer Overflow. Sometimes you'll get random items in your inventory, or your coins just disappear. Even the dialogue can stop working and show random gibberish. This must surely be the work of magic. McHoneybell doesn't look convinced. After some thinking, she seems to know what this is all about. All right, am I missing anything on the chat? Z said, Buffer Overflow is new to me. Computer first, go to computer, get 16. Yeah, sorry, guys. I always look at the chat after I'm done reading. J So said, that's how mine works most of the time. And use tab to do the debugger. Cool. Good to know. I think I saw that in the instructions. Reckless Gizmo said, BRB, roundhouse kicking my PC for a crisp $5 bill. I mean, that's basically what I did when I made my rap song. Just made money. I'm basically a millionaire at this point. Even though I have monetization turned off on it because I don't own the beat. But, is what it is. Memory corruption. Remember that whenever we execute a program, this game included, all data will be processed somehow through the computer's RAM, or random access memory. In this video game, your coin count, your inventory, your position, your movement speed, and direction are all stored somewhere in the memory and updated as needed as the time goes on. Andre said, when you hit the computer 16 times, this is my computer most of the time. I feel you, dude. All right. Usually, each variable stored in memory can only be manipulated in specific ways as the developers intended. For example, you should only be able to modify your coins by working on the PC or by spending money either in the store or by changing your name. In a well-programmed game, you shouldn't be able to influence your coins in any other way. But what happens if we can indirectly change the contents of the memory space that holds the coin count? What if the game had a flaw that allows you to overwrite pieces of memory you are not supposed to? Memory corruption vulnerabilities will allow you to do that and much more. Honeybell says the debugger will be needed to check the memory contents while the game runs. On hearing that, Van Spreekle says they programmed a debug panel into the game that does exactly that. This will make it easier for us. There it is. You guys see that? Oh, I see. Wonder if we have to sort out bad characters and such, or if we just straight pwn it. Okay, accessing the debug panel. While they were developing this game, the Frostings added debugging functionality to watch the memory layout of some of the game's variables. They did this because they couldn't understand why the game was suddenly crashing or behaving strangely. To access this hidden memory monitor, just press tab. We did it. You can press tab repeatedly to cycle through two different views of the debugging interface. The ASCII view, the memory contents will be shown in ASCII encoding. It is useful in trying to read data stored as strings. And we can see that. Scrooge rocks. And then you can see if we overflow our name, we can go on to this other stuff. I'm guessing that's how we're going to end up doing it, because it shows us hey, how do we get to coins? And you can see the reason we get 33 coins when we update our name, if I'm understanding this correctly, is we're overflowing the player name buffer and we're putting exclamation mark into the coins, which is modifying it. So if you make a really long name, then you can modify everything, make everything ones or something like that. And then we have hex view. And the memory contents will be shown in hex. This is useful for cases when the data you are trying to monitor is a raw number or other data that can't be represented as ASCII strings. Jeez, my cat just meowed super loud. All right. Viewing the contents in RAM will prove helpful for understanding how memory corruption occurs, so be sure to check the debug panel for each action you make in the game. Remember, you can always hide the debug panel by pressing tab until it closes. Investigating the Scrooger Rocks case, which I may have already just done on my own. That's how hackery I am. Armed with the debugging panel, McHoneybell starts a lesson. As a first step, she asks you to restart your game. Refreshing the website should work, and open the debug interface in hex mode. Oh, okay. I'm going to have to do this. Can I just do this? There we go. So you can see this, guys. Our coins are that character, but we're giving an exclamation mark, overflowing our player name buffer. I think that's what it's going to tell us. The frostings have labeled each of the variables stored in memory, making it easier to trace them. McHoneybell wants you to focus your attention on the coins variable. Go to the computer and generate a coin. As expected, you should see the coin count increase in the user interface and the debug panel simultaneously. We know where the coin is stored. You should see the coin count increase in the user interface and the debug panel. I don't see it going up in the debug panel. Am I crazy? Oh, there it is. Right there. So if we get enough, like 33, you can see it. The hex is updating here. McHoneybell then points out that right before the coin's memory space, we have the player name variable. She also notes that the player name variable only has room to accommodate 12 bytes of information. But why does this matter at all? Asks the confused Van Twinkle. Because if you try to change your name to Scrooge Rocks, you'd be using 13 characters, which amounts to 13 bytes, replies McHoneybell. Van Tinkle, still perplexed, interrupts. So, what would happen with the extra byte at the end? McHoneybell says, well, it will overflow the first byte of the coin's variable. Duh. To prove this point, McHoney proposes replicating the same experiment, but this time we will get 13 coins and change our name to ABCX. Meanwhile, we'll keep our eyes on the debug panel. Let's try this in our game and see what happens. All right. Let's try it. Oh, although I have too many coins, mine's going to be weird because I have 15 coins, so it's not the same memory. We'll still do it. A, B, 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 C, 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 X. Oh, it still worked. Okay. And you guys can see that if we look at, we see this X here, we've overflowed that buffer. All of a sudden, we have 120 coins. The memory space of the coins variable now holds 78. Remember that 0x78 in hexadecimal equals 120 in decimal. To make this even more clear, let's switch to the debug panel in ASCII mode. The x at the end of our new name split over into the coins variable. The ASCII hexadecimal value for x is 0x78, so the coin value was changed to 078 or 120 in decimal representation. As you can see, McHoneybell's predictions were correct. The game doesn't check if the player name variable has enough space to store the new name. Instead, it just keeps overwriting the values of other variables. This vulnerability is known as Buffer Overflow and can be used to corrupt memory right next to a vulnerable variable. Buffer overflows occur in some programming languages, mostly C and C++, where the variable's boundaries aren't strict. If programmers don't check the boundaries themselves, it's possible to abuse a variable to read or write memory beyond the space initially reserved for it. Our game is written in C++. All right, I'm going to look over at chat. Z said, go to the green guy. I got the star with 9 coins. Nice, dude. Check LinkedIn. Make sure I'm not missing anything over there. All is good. Let's keep going. Strings in more detail. By now, the Frostians look baffled. It never occurred to them they should just check the size of a variable before writing to it. Van Tinkle has another question. When the game started, the main character's name was cat or mouse, which only uses 10 characters. How does the game know the length of a string if no boundary checks are performed on the variable? To explain this, McHoneybell asked us to do the following. Restart the game. All right, we're going to do every step here, guys, especially for those who might be new. I want to replicate every step. We're not going to move ahead. Restart the game, get at least 3 coins. There we go. 3, change your name to Elf. Elf or mouse. As a result, your memory layout should look like this: elf, mouse. When strings are written to memory, each character is written in order, taking 1 byte each. A null character, represented in our game by a red 0, is also concatenated at the end of the string. A null character is simply a byte with the value of 0x00, which can be seen by changing the debug panel to hex mode. Whoops. There we go. You can see it right there. Okay, here's where we're at. When reading a variable as a string, the game will stop at the first null character it finds. This allows programmers to store smaller strings into variables with larger capacities. Any character appearing after the null byte is ignored, even if it has a value. To better explain all this, Ms. Honeybell proposes a second experiment on strings. Get 16 coins. That's our first quest. 1, 2, 3, 4, 5, 6, 7, 8, very exciting, 9, 10, 11, 12, 13, 14, 15, 16. Oh no, the PC is broken. Now your memory layout should look like this, blah, blah. Notice how the game adds a null character after your 16 bytes, which overwrites the shop key name. If you talk to the shopkeeper, you should see his name is empty. And my computer's broken. Is the shopkeeper the blue guy? I don't do that. I don't think it worked. I don't think their experiment worked. Oh, I need to rename myself. What am I doing with my life? Gosh. All right, here we go. A, B, 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 C, 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 D, 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 D. Oh, look at that. Would you just look at it? Doo-doo. What up, bruh? Yeah, your name is blank, homie. Fix your name, noob. Okay. This happens because the game reads from the start of the variable up to the first null byte, which appears in the first byte in our example. Therefore, this is equivalent to having an empty string. On the other hand, if you talk to Van Holly, you should see your own name is now A, B, C, which is 16 characters long. Since C++ doesn't check variable boundaries, it reads your name from the start of the player name variable to the first null byte it finds. All right, so it's reading, it's reading, it's reading, it's reading. Stop right there. You see, we make it null. And because this is a null byte, well, the shopper's name, remember, it stops reading a null byte. So all of this is that. If you spend money, okay. Buy some items and see what happens. Yeah. So you can see my name change there. Van Tinkle mistyped the name during the previous experiment and ended up with that. Then they noticed that they had that many coins in the upper right corner. What? Shown as follows in the debug panel. Out of curiosity, they use an online tool that converts hexadecimal to decimal numbers to check if the hexadecimal number from the debug panel matched their coin count. To their surprise, the numbers were different. McHoneybell explains that integers in C++ are stored in a very particular way in memory. First, integers have a fixed memory space of 4 bytes, as seen in the debug panel. Secondly, an integer's bytes are stored in reverse order in most desktop machines. This is known as little endian byte order. Let's use an example to understand this better. If you take your current coin count of that and convert the number to hex, you'll obtain that corresponding to what's shown by the debug panel, but backwards. How many coins do you have? The hex value of the coins variable is showing in memory as follows. Input your answer at the end of the task. Okay, so 4F, 50, 53, but it goes backwards, right? If you take the current coin count and convert that number to hex, you'll obtain that, corresponding to what's shown by the debug panel, but backwards. Let me understand this hex example real quick. 4, where are we getting that number from again? Oh, from the debug panel. 445. Okay, let's just do this experiment so I can actually see it debugging myself. So what do I need to do? Change my name again? Oh, wait, I have all the monies. Oh, I got you. Word. All right. So we're going from this one right here. So it's saying, if it looks like that, what is it? So we need to convert it from hex to what? ASCII? No, hex to that. So, oh wait, it would be 53, 50, 4F, 4F. Is that the answer? Hey, I'm smart. Figured it out. Winning the game, McHoneybell is about to wrap up the lesson and call it a day. But first, she explains how an attacker can now overwrite any value in the coins variable and have enough to buy the star and finish the game. On hearing this, McGrady starts laughing, ha 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 ha, and tells McHoneybell they rigged the game so nobody could win. McHoneybell is more than welcome to try to purchase a star, McGrady says. Confused, McHoneybell does some quick calculations and concludes she should be able to get enough coins. She looks at you and asks you to show how the vulnerability can be exploited. You notice that she looks a little doubtful, but still, it's now up to you to win the game. Can you get a star in your inventory and prove McGreedy wrong? I think so. So our inventory items are here. Right? And the ID is D. Can I just replace everything with a D? YOLO it. That didn't work, guys. I'm going to have to reset the game. So we probably have to go all the way down to here and then do a null byte. Is what I am thinking. Can I fix this by updating my name again? Okay, so that goes back to there, and then we have the null byte. So what do we need? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. Inventory items have A, B, C, D, F. Inventory items have A, B, C, D, F, 8, 9, 8. Oh, so it's just that. Yeah, I should do straight D's, but it doesn't like that. But all we need is Did I do Z's? Didn't I do D? Or did I not do D for some reason? Maybe Z over in chat confused me. But if we do A, B, C, D. I did Z's. Why did I do Z's? Yo, Z, over you in the chat, I think I must have looked at you. Like I was looking at the chat and saw your name. Because I saw clearly it's a D. It gives you that hint right there. ID of D. Let's just spam this. See what happens. YOLO it again. Yeah, that's what I tried to do the first time. There. Why would I do Z's? I'm blaming Z over there. But I won, I think. Oh shoot, but I broke the chat. I can't see the flag. The flag's right there. But I can't read it because I broke it. We have to do less D's. No, we have to just restart the game. I think I just broke the game. Let's restart the game and then D it up again. Oh, I can't. Thanks, dude. We need to get that 100 coins real quick. I need other characters. I can't just D it up, dude. Yeah, I get insert a shell code. So you're telling me I can't do this? Oh, that's not enough characters anyways. I'm gonna web app hack my way to the flag. Just kidding, that's not gonna work. Why can't I just put D's, bro? I like just doing D's. Okay, sorry, I'm missing chat. Default selects the challenge really got me stumped. The hex number and the coin selection of the debugger did the same. Note, now I refresh the page, you crash it. My idea is try to override the values in memory if I got to count how many I needed. Unintended solve. Try reading the source code. Maybe it's readable there. Just leave it pressed. That's what I was thinking, dude. Maybe it is readable in the source code. Nope. Okay. I don't know why I can't just do D's, guys. I don't. What if I just do D's down to this point? Right? So we got rows of 4. I know I'd have the flag if I listened to you, my friend, but that takes away all the experimenting stuff. And that's the fun of doing this, is experimenting and screwing around and making mistakes. Not just getting the flag right away, in my opinion. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. I can't do that math in my head, guys. Gonna pull up my phone because I don't like using my host machine on stream. Apparently my phone doesn't have a calculator. Here it is. So 44. What I'm going to do over here, I need exactly 44 A's. All right. Now we need to change my name first, right? I need 44. Okay. I have lots of money now. Can I copy and paste it in this window? I had ChatGPT make me 44 lowercase a's. Oh, I need D's. Why do I keep switching this up? Okay. Sorry, you guys can't see my ChatGPT conversation on my other screen, but... Oh, I can't paste it? All right, we're going to count this out. 1, 2... I was one off. I was one off. I need 45. But my chat's still right. Okay. Hey, what do you guys think about that? I got the flag my own way with all D's. That's what I'm talking about. Boom. That worked in my head. I'm glad it worked in real life. A lot of times when things work in my head, they don't work in real life. What was the hint? Oh, okay. I've only explored buffer overflows. I think I did this room. Let's find out. No, I didn't. I think Tiberius has a room for OSCP prep, and that's the buffer overflow room I did. Vanjali still thinks a ghost of Christmas Past is in the game. She says she has seen it with her own eyes. She thinks the ghost is hiding as a glitch, whatever that means. What could she have seen? I don't know. Let's wander around. Can we go in this house? I don't know. I don't know where the ghost of Christmas past is. We're just going to call it a day. That's probably the side quest. You're probably right. All right, guys. We are at 40 minutes, and we have completed day 6, memory corruption. I didn't even have to watch the video, so that's a win. And I did it my own way by just throwing D's at it after manually counting out the number of D's that I did. So, guys, hopefully you enjoyed this. Hopefully you learned something new in the process or learned something from my mistakes, because I'm blaming Z for the first time doing all Z's. He distracted me in the chat. I saw his name and thought I needed to do Z's. Want to make sure I'm not missing anything in the chat. And do just want to say, guys, quick announcement. I will be live on stream tomorrow twice. So I'll be live actually during the day, guys, at 2 p.m. Central Standard Time. So whatever time that is in your time zone, 2 p.m. Central Standard Time, I'll be interviewing Tori Fisher live on LinkedIn, Twitch, and YouTube. She is the Director of Operations at Rhino Security Labs. We're going to talk about all things pen testing, how you can break into the field of pen testing, how you can grow in your career if you're already a pen tester, what a project management manager does, how you might become a project manager if you feel drawn to pen testing, but maybe not the highly technical work, but still like working with clients and doing things like that. We are going to talk all about it, as well as take your questions in the interview. There's a link on my LinkedIn. I just shared it today with the event information. But hey, we'll love to see you guys. We'd love to have you join me. So once again, that is tomorrow, 2 p.m. Central Standard Time. And then I'll be back again for the 8 p.m. Saving Christmas. So I'll be on stream twice tomorrow. Hope to see you guys at both of those. Come hang out. Come join. Would love to talk to you then. But once again, guys, thank you for being here. And yo, I'll catch you guys tomorrow, hopefully twice. I'll see you then.